Hello again everyone. In today's lecture, we will discuss about some of the commonly used terminologies in your data communication. I mean, when your data communicate from the sender to the receiver, right? The common terminologies that are, or the common terms that I use here. So we'll start with the first one, what you have already learned in the definition of a network. In definition of a network, if you can recall, I have mentioned that you have two devices communicating body, and then in order to transfer the data from this computer to another computer, you have to connect them with the help of a transmission medium. And this transmission medium here is called as your channel, communication channel or your transmission channel. And like what we have already discussed, this channel can be either connected using a wired connection, that means different type of cable, your twisted, your coaxial, your optic fiber, or they can be connected with the help of a wireless connection. Your infrared signal, your radio wave, your microwave, satellite connection, your Wi-Fi, your Bluetooth, etc. And your this channel here can transmit data either in unidirection or in both the direction. That means the data here will be transmitted either in only one side, and to transmit the data on the other side you will need another cable, or you can use the same cable in order to transmit the data to both sides. Now, whereas in case of your wireless connection, we have learned that your wireless connection can be used to transmit data either on a line of sight basis, that means in a straight line, or the signal or the data here can be transmitted in all the direction. So this is what your transmission channel or your communication channel is all about. The next one is the bandwidth. Now take this example here. Consider this example here. This say is your communication channel. Fine. This is the communication channel that is provided to you for you to transmit your data from the sender to the receiver. Now out of this allotted transmission channel, I mean your this say is your wire. Now depending on how much amount, how much capacity is allotted to you, and in order to transmit the data, because you will not be using the entire channel, right? So what you need to do here is a separate or a specific number is allotted for you to transmit your data from the source to the destination. Now the amount of data that is allotted to you out of the already existing channel, how much is given to you to transmit your data, will be referred to as a bandwidth. So bandwidth can also be referred to as the range of frequency available for data transmission. Now if you recall, in case of your radio wave, right, separate frequency will be allotted, right, for transmitting the data. So likewise here, the amount of frequency, how much is allotted to you out of the already available communication channel, how much is given to you to transmit your data from the source to destination, will be referred to as your bandwidth. Now here your bandwidth is measured, I mean the data that will be transmitting here will be measured in bits per second, so which is also referred to as hertz. Now the greater the bandwidth here, I mean if you have more bandwidth, the faster will be the transmission of data from the source to the destination. That means if you are allotted with more bandwidth here, more amount of data can be transmitted. So that means your data will reach faster to its destination. So this is what bandwidth is all about. So it is measured in either hertz or kilohertz or megahertz. Data transfer in, yeah, this is actually very simple from the name itself. You can easily understand. We are referring here to the amount of data in its digital form. When you transmit it from one computer to another computer, it will be transmitted in the form of your 0 and 1 combination, and it will be received also in the form of ones and zeros and 1 communication. That means the amount of data in its digital form that is moved from one place to another in a given time on a network. The given time are normally per second. Right? The amount of data that you can transmit in second. Now since we are transmitting the data in the zeros and 1 communication, so this will always be measured in bits per second. How many bits, how many 0 and 1 combination reach the destination in every second, right, is referred to as a data transfer rate. So this is measured in bits per second. Now in here I want you to find out what are these. Fine. kilobits, megabits, the gigabits, and the terabits. How many bits per second is equal to kilobits per second? Likewise, how many bits per second? Okay, this has to be small letter. How many bits per second is equivalent to your megabits per second, gigabits per second, and terabits per second? So this will be the assignment for today. Okay, other than that, what you have here, in order for you to transmit your data from the source to the destination, there are different ways of sending the data across the network. Right. So this technique here will be used in order to, like, based on what technique you'll be using here. Right. So the technique that you use here will allow you to transmit the data more efficiently compared to another technique. Fine. Other than these two that I have listed here, the circuit switching and the packet switching, there is another type which is called as the message switching, but that is not in your syllabus. So we'll discuss only about these two common switching technique. Fine. I mean the different ways of how data is sent from the source to the destination within the entire network, how exactly things are connected. Fine. So we have the circuit switching and the packet switching. In circuit switching, example of this is when you make a call, say when you try to make a call from here to someone else on the other side. Normally, initially what happens is there will be a telephone exchange office. Right? So whenever you try to connect a call, the telephone exchange operator will connect your call to the actual connection. So this is what is happening here. If you're making a call, it'll go to the first operator. The first operator will connect your line to this here, this port, and likewise this will be transmitted to the next transmission operator. I mean depending on how many switching offices are there in between. So this will be connected to this, and likewise this to this to this, and from here this will be connected to this, and finally this will reach your destination here. So what we are doing here is, before we make a call from here to here, before you get to speak to the person on the other side of the line, there have to be a physical connection that is to be set up. Fine, that means you have to already fix a route from before. Once the route have been fixed, then you will be able to make the call. Once you're able to connect to this person, no one can disturb you in between the call. That means if someone tries calling you when you're busy with someone else, fine, the other person will not be able to connect to you. That means your line here is dedicated to this particular call. Only maybe after you have hung up, then the other person can make a call to you. Otherwise, once this has been set up, so this will be totally dedicated to you making a call to this other person. So this is a circuit switching. Here we have already discussed, it's dedicated and a complete physical connection has to be established before you make a call. Fine, it's like you have to have an already, a setup or connection from before. Once you have the connection, then only you will be able to make the call. This part guarantees the use of full bandwidth. That means whatever route has been allotted to you, you will be able to make use of the entire bandwidth that is allotted to you. Channel will always remain available to other user. Right? Once you are connected to the other side, your this channel remains unavailable. No one else can make a call. No one else, can use this particular route. This is like what I've already mentioned is implemented in your telephone exchange center. Fine. Now the main problem with this part is, suppose if you are not making any call also. When if you're not making any call, because this route has been allotted. Find this one here. This has been allotted for you to make a call from this side to this side. So even if you are not talking to this person, this route will be dedicated only to you making call to this person. I mean this route cannot be used even if you're not speaking to this person. In order for someone else to make a connection, or in order for you to connect to someone else, you will have to find some other route. The reason is because this one has been allotted only for connecting from you to this person. If you want to connect from you to another person, there has to be another route. So what happened here is, as long as you're not making any call to this person, this particular route here will remain idle, but it cannot be used by anyone else. So what we are doing here is we are wasting the bandwidth. No one can use this. Fine, this is already allotted to someone else. That is the main disadvantage of using a circuit switch. Now, in case of the other one, a packet switch here, what you have is when a message is transmitted from the source to the destination, that means from the sender to the receiver, we will not be sending it as one message, but a message here. The message will be broken down fine into smaller blocks, and each and every one of these blocks is referred to as a packet. Fine, every one of this is referred to as a packet. Now, every packet here will have this list. Each and every packet here will consist of a header and a data. Header here will consist of the destination address, that means where you want to send a message, the sender's address, and at the same time what we have called a sequence number. Fine, a sequence number. I'll tell you what is that. And then after that the data, I mean what you are trying to transfer. Now once this message here have been broken down into smaller packet, it is not necessary that all of them will travel through the same route. Here we have this one packet, they will travel through this route, second packet might travel from this route, third packet might travel from some other route. Since there are endless number of ways trying to transmit from sender to receiver, so this packet might travel through a different route, and I mean a different path. So once they reach here, they will be assembled together. See, when they reach here, they might not reach according to the sequence here. If this is number one, it's not necessary that this will be the first one to reach here. It might be some other message. So because of that, we have allotted the sequence number so that when the message reach the receiver based on the sequence number will arrange the message. Then only the message here will become meaningful. Fine. Now in this case, unlike that of the previous one, the circuit switch, you don't have to set up all this route from before. Any available route can be used for sending the message from the sender to the receiver. This is the main advantage of this. Right? Any available route, you don't have to fix it from before. Every time you want to send a packet from a sender to receiver, you can use any route. Suppose if this is busy, then definitely you can go through another route. If this is busy, you can go through another route. Whereas in your circuit switching, if the route is busy, you will have to wait for that particular route till it becomes free. So this is what we have. Your message here will be broken down into packages with a limited block size. Each and every packet here will have a limited size. Packet here contain a header, what I've already mentioned, which consists of the source address, the destination address, the sequence number, and there will be many more technical stuff that will be included there. And the data link here is shared with other traffic. Each and every message here, okay, that means each and every connection is being shared by everyone. Each packet in a data stream is independent. Not necessarily that the packet will travel through the same route. They can travel through a different route. Now the problem here is that if say I try sending the message, say if I have only this particular route here, okay, this two route. Now if this route are busy, or I mean there are so much traffic here, what will happen? There will be a time allotted for this particular packet, that it have to travel from the sender to the receiver within that allotted time. Now if they are still stuck in the traffic within a particular time, within those allotted time, then what happens is they will never reach the destination. So the message have to be dropped. So this is the meaning of that. If the network becomes overloaded, the packet are delayed, and at the same time if they are very late, if they don't reach the destination at the allotted time, they will be discarded. I mean they'll be dropped out, they become useless. This is the most common switching method that is used in today's technology. So these are implemented in the internet as well as your LAN connection. The packet switch. One is a circuit switching, another one is your packet switching. Packet switching is what is being implemented, okay, in all the technologies that is being used nowadays. So with this, we'll stop here for today. Thank you very much.